Class, what is your GCF of your A and B? 7 what? 7x. Okay, now this is just to the power of 2, and I know it does say 7x. You can do that. So 7x squared, and I would have to put what out here? Nothing, right? So 7x squared plus 5 times 7x plus 6. And you see how what's in the parentheses is the same. So that means my z value is equal to what? Now the z value is just a variable we chose. So now I'm going to replace it. So every time I see 7x, I'm going to write what? Z. So let's write that. Z squared plus 5z plus 6. Class, now to factor that, you can just use the box method. Joe, A times C? You're looking here on this line. Your A value is 1 times C is 6. Your B value? Joe, 2 numbers that multiply to be 6 but add to be 5. So now I can write Z plus 2, Z plus 3. And then we just go back and substitute the z value. Joe, tell me what to write.
7x plus 2. And 7x plus 3.
Raise your hand if you got that. Now, here's a great thing. If you don't understand this chunking method, basically it's a substitution before you factor. You can do no chunk, which just means you're going to use a big X in a box. Let's try it together. I'm going to write the original problem here. Oh, you see it right here. Okay, numbers get very large, don't they? 49 times 6. And class, your B value. If I were doing the problem, I'm going to write out all the factors. I know 49 and 6 is going to be one of them. 147 and 2. Echo? 98 times 3. Thank you. 21 times 14. Did we find it? What is it? These 21 times 14 gives you 294. 21 plus 14 gives you 35. So again, when the numbers get large, do this method. These two go here, and you're going to add an x. I'm going to put in the first term. Class, what goes here?
6.
The last term, right? 6. And now we just need to pull out the greatest common factor. And you can always double multiply to check your answer. 49x squared, 14x, 21x, and 6. So my answer. And does that come out to be the same answer as the chunking method? So I will not ask you on a quiz or test, I will not say, show me the chunking method. Why? Because if you don't get it, you can still do it this method. But let's talk about this. Were those numbers easy to work with? No, they were not. It's still doable, but not easy. That's why they invented the chunking method, it's a substitution. Question?
Let's say 49x squared wasn't 49x squared, it was 48x squared. And I reduced it because 6 was into all those 3, and then I did the no chunking method. Would that still work?
Correct, but I think when you said you made up a number,
Yeah, 48.
yeah, chunking method wouldn't work, but you're saying if there was a greatest common factor, pull that out first? Yes, I would do the greatest common factor first.